Hey guys, it's me, Margaret, and I'm here to teach you more about ellipse, which is one of the conic sections. Let's define ellipse. Ellipse is a plane curve surrounding two focal points such that for all the points on the curve, the sum of the two distances to the focal points is a constant. Ellipse has 13 parts and I am going to show you all of them, so let's proceed to the video.
Ellipse has two orientation similar to other conic sections which are horizontal and vertical. The general form of equation for ellipse is ax squared plus cy squared plus dx plus ey plus f is equals to 0. The standard form of equation, which center is at the 0, 0 or at the origin, is x squared over a squared plus y squared over b squared equals to 1, which is used for horizontal orientation. For vertical orientation, we use x squared over b squared plus y squared over a squared equals to 1. The standard form of equation, which center is at hk, is x minus h squared over a squared plus y minus k squared over b squared is equals to 1, which is used to horizontal orientation. For vertical orientation, we use x minus h squared over b squared plus y minus k squared over a squared is equals to 1. The parts of ellipse are center, vertices which are the endpoints of major axis, and co-vertices which are the endpoints of the minor axis, the foci, latera recta, directrix, and eccentricity. I did say that we have 13 parts of the ellipse because center has 1, vertices has 2, co-vertices has 2, foci has 2, latera recta has 4, directrix has 2, and eccentricity has 1. First example, we have 16x squared over 16 plus y squared over 16 is equals to 1, and it is vertically oriented. First, we have to find the value of a squared, b squared, c squared, and also the value of a, b, and c. A squared is 16 because it came from the value of y, b squared is 1, came from the value of x, c squared is 15 because we subtracted a squared and b squared. The answer for a, b, and c are the square root of a squared, b squared, and c squared. To answer all the parts, we have to depend on the table. For the center, we have 0, 0, vertices is at 0 and 4, 0 and negative 4. The co-vertices is at 1 and 0. The second co-vertices is negative 1 and 0. The foci, first foci 0 and square root of 15, and second foci 0 and negative 15. The first latera recta is 1/4 and square root of 15. The second, negative 1/4 and square root of 15. The third, 1/4 and negative square root of 15. And the fourth, or the last one, is negative 1/4 and negative square root of 15. The directrix are positive negative 16 square root of 15 over 15. The eccentricity is square root of 15 over 4. This is what it looks like when we graph it. Here are the parts of the ellipse which center is at each K. It is just the same with center as 0, 0. The second example, we have x minus 3 squared over 16 plus y minus 2 squared over 9 is equals to 1, which is horizontally oriented. Just like the first example, we have to first find the a squared, b squared, c squared, and the square root of it for the a, b, and c. The center is at 2, negative 3, vertices 7, 2, negative 1, and 2. For the covertices, we have 3 and 5, and 3 and negative 1. For the foci, first foci is 3 plus square root of 7 and 2. Second foci, 3 minus square root of 7 and 2. 3. First lateral recta is 3 plus square root of 7, 17 over 4. Second, 3 plus square root of 7, negative 1/4. Third, 3 minus square root of 7, 17 over 4. Fourth, 3 minus square root of 7, minus 1/4. The directrix are 3 plus 16 square root of 7 over 7 and 3 minus 16 square root of 7 over 7. Eccentricity is square root of 7 over 4. This is what it looks like when we graph it.
Thank you guys for watching. I hope you learned something from my video. Bye!